So today we're going to talk about ecosystem and how all of us in the robotics community can be working together to solve some big problems, whether it's in healthcare or in logistics or agriculture. More collaboration will result in better results for everyone. And let me start by setting up where I think we are. This idea of a Cambrian explosion in robotics. And I think this is very similar to, if you look at the arc of computing, right? You used to have mainframes, where very few companies could afford one, they were very expensive, hard to maintain. And then now, obviously, we have supercomputers in our pockets and on our wrists. So I think with robotics, we're seeing something similar. From the original industrial robots for manufacturing to cobots, so that's Baxter, by the way, to some of these now ubiquitous robots. You can get hundreds in one location, sometimes all working together. So I think what we need to see is more of this evolution. And the more you have, the more mix of different types of technologies you're going to run into. The other thing that's, to me, really exciting is this idea that robots are essentially busting out of factories, right? They're no longer just used for manufacturing, just used for welding parts to cars. You see all of these very large industries that in many cases had very low levels of automation, as we know it, that are now getting into the action. And obviously manufacturing has a big lead there, but there's many use cases in manufacturing that haven't been fully automated. But then you look at what's been happening in logistics. I don't know how many of you were at Modex this year. So this used to be a show about steel shelves and forklifts, and now it's 90% robotics, right? And then when you look at healthcare, not just the clinical aspects, but the logistics aspects of running a hospital, which is almost like running a small town. Then I'm excited about agriculture and retail. So what's really interesting is all of these industries can benefit from robotics. And I think there's a lot of talk right now about AI. I don't know if anyone has heard about it. But to me, what's exciting is, ChatGPT can move pixels on a screen, but robots can actually feed us or build housing for us or help look after us. So we need, some people are calling it embodied AI, right? So AI for the physical world, and increasingly that's being, what's called software-defined. So I call it software-defined anything, right? Software-defined X. So whatever you do, to write software or use AI to control the physical elements. So let's maybe dig into a particular scenario with a warehouse. And I'll use InOrbit as an example here, but you think about a warehouse and you have enterprise systems that have existed for a while, and then you get all of these different robots, and then you get this kind of like interconnect of anything to anything takes a long time. So apologies to any systems integrators in the room, but a lot of times you get this robot talking to this WMS, and it takes 6 months, and people are working on it, so it's a lot of work. But then you get this other robot, and you need to start over. What we're proposing is an easier way, which is having a software abstraction layer that helps connect anything to anything. And then you build one integration with each system, and you put things together. So in order to make situations like this work, what we really need is not just better tools, but also better practices, better mental models even. So we try to advance this idea, what we call RoboOps. And if there are any people from IT here in the room, you'll recognize the term DevOps, right? Which really revolutionized how software is delivered and maintained. And so in the bad old days, software development, you would write a piece of code, and I'm a recovering engineer myself, so I can relate. Write a piece of code, you're done, it works on your computer, you toss it over the wall, and it's somebody else's problem now. And if you're running a website or an app and it goes down, it's ops problem, right? Not yours. And then maybe they yell at you, but you're not on the hook. And again, you can always go back to, it worked on my computer. So DevOps changed that. And the idea was you have tools that give you visibility across everything from end to end. And you have teams that are integrated. Now, in robotics, it's a little tricky, right? Because you may have a robot developer on one side, you have an end user on the other side. And the end user doesn't necessarily know how your robot works. But the robot developer needs data from the field to resolve problems. So what we're trying to do is bring some of these practices that work so well, let's say, to scale the cloud. Without DevOps, we wouldn't have the scale of the cloud that we have now. And then think about what that looks like in a robotics environment. And you can think of the left side of the diagram as you're making a robot and you're getting it out into the world. And the right side is about your running your business using robots. And then these two feed each other. And again, I think what's important here is you need to have the robot developers and the end users working more closely together. So I think that's the first part of the ecosystem. I know a lot of robotics companies think of end users as customers, and they are because they're buying the robots. But I think what's needed is more of a partnership, right? We're part of the same community to some extent. And that means thinking about what data is available to each of them. Maybe not every data that robot developer needs will be useful or necessary or appropriate for an end user. And likewise, maybe it doesn't work in the other direction either. But in general, the flow of the appropriate amount of information will make this thing go better. And it's no accident that this is in the shape of an infinity loop. A, because you're never really done, right? When you deploy robots, there's always something else that you can do operationally to improve productivity or reduce incidents or whatever it might be. And I think we need those two sides working more closely together. Now the reality is, if you think about an end user, they're not, like if you are an end user here in the room, or if you're walking around the floor, not everyone is at the same point. And while everyone's journey is a little different, we've found some similarities. And typically, you will start with a single robot and a single site, right? That's, I think, where most people start, which is, are robots right for me? And I think we saw before that more and more industries are saying yes to that question. But for an individual company, you need to assess whether that's going to help right now. Then it's like, okay, if one robot worked, then maybe many robots will do more work, right? So that's a natural, I would say, extension, more of the same. But you're still kind of in that original site. Things start to get more complicated. Now you're deploying nationally or globally. You're deploying your robots in different locations for different environments. You can't just take an elevator and see how the robot is going. If it's stuck, you can go and kick it to see if it starts working, or reboot it manually. So now you're saying, okay, so things are getting a little bit more complicated, and are about to get a lot more complicated, because once you're at that point where it's like, okay, you have robots, you're scaling, right? You went from one side to many, one robot to many. Then you're like, if I was able to, let's say, move pallets with robots, can I move individual items with robots? And the answer is probably yes, but it may not come from the same vendor. So all of a sudden, you're multi-robot, multi-site, multi-task, and multi-vendor. It's almost like the multiverse. And things are complicated here, right? So you need to, on the one hand, just get the robots to get along with each other. I call it the 3 C's of orchestration. So first is coexistence, right? Then it's like, okay, maybe, here's a good example. So we work, for example, with retailers. And a large retailer may have robots for inventory restocking. They may also have robots for, let's say, cleaning the floor. Now, if you think about a retail side, you have these aisles. You really don't want the 2 robots on the same aisle at the same time. So it's better if they coordinate their work so that they take turns. You have even more advanced use cases where to complete one task, you need different robots from different vendors working together, right? Neither of the 2 robots can accomplish the task on their own, but together they can. So again, this is with the idea of ecosystem and better together. I think this is, I would say, a higher level goal to aspire to. All right, so let's go a little bit more in detail. So it takes a village to run a warehouse, right? So if you think about the flow of goods, and we're going to start on the right, goods are entering the warehouse, right? So before they enter the warehouse, you have, trucks trying to, bring in their trailers, right? And usually you have a limited number of cargo slots, cargo bays, and you have more trailers than you have cargo bays, so you need to manage that. And there's companies that are doing yard management automation with autonomous, basically tractor trailers. Okay, so you have that trailer on the cargo bay, and you need to unload it. Again, the old-fashioned way. The old-fashioned way of yard management is there's somebody sitting on the truck. There's a long line of trucks, and everyone's diesel, so they're idling for 2 hours. Dropping off the trailer and moving on is better. Same thing with trailer unloading. You can have people driving a forklift, picking a pallet and pulling it out, or you can have an autonomous forklift. Turns out there's several companies that all they do is trailer unloading. But there's a group of companies that unload trailers with pallets. There's another group of companies that unload trailers with cases. So, okay, so we're not even in the warehouse yet, and we already have multiple vendors, right? And then you're stacking pallets on the floor, or you're depalletizing, and when you depalletize, what do you do with leftover material, and how do you make sure that you're not missing inventory? So you get the picture. It gets complicated. And again, there's multiple vendors in each of these different categories to choose from. And what you choose today may not be what you choose 2 years from now. So if you build an integration that only works with that one vendor, and then there's another one that's better, faster, better fit for you, you're gonna have to rebuild. So that's one of the challenges. So even though each robot vendor if you're a person to, or goods to person system, right? You really don't care about anything else that's going on in the warehouse, because that's your world. But the end user has a warehouse to run, not a goods to person system. So that's where it gets complicated. And this was just an example with warehouse. I'm not going to do that level of detail with all of the scenarios, but each of these, to some extent, is its own unique challenge and situation. So far, so good? All right, so here's the problem. When you add more robots, you don't just grow, you don't double. When you have 2 robots, you don't double your complexity, you at least quadruple it. And it gets worse with more robots and types of robots. So it's really, really hectic, and it will lead to frustration. What I recommend as the cure for frustration is orchestration. And again, the idea here is if you can make all of this work together in harmony, you may need a conductor to make it all work together, but if you make it all work in harmony, everyone, no matter which department you're in, right? Whether you're responsible for deploying the robots or responsible for the throughput of the warehouse, whatever you are, you don't really want that cleaning robot to enter your cargo area just as you're moving pallets off of the truck. So even a basic case like that is necessary. All right. I use this word orchestration. I get asked a lot about interoperability. I work on interoperability standards for mobile robots, but I try to make a distinction between the two. So to me, orchestration is this higher level idea of coordinating robots, but also the environment in which that robot exists. And to me, there's a software environment. So if you're in a warehouse, there's a warehouse management system. If you're in a hospital, there's an electronic medical record. There's always not one, but many different systems usually to manage the operations. So the robots need to talk to that. They need to talk to each other. They need to talk to the infrastructure. Right? So you may need to traverse a door. You may need to ride an elevator. And how do you get everything working together? Interoperability, besides having way too many syllables, my opinion is more like what engineers care about, which is the technical details. This robot said, beep, and then the other robot understood what that was. You can do orchestration without interoperability, and that's a little counterintuitive, right? You can have 2 completely different systems that never knew anything about each other, never agreed on anything, and then you can have that conductor making the connections between all of this. Things are a lot easier if you can get everyone to speak the same language, right? But for example, for InOrbit, I say that what we do is we're like the Google Translate for robots, right? So we can talk to each robot in their own language and then make it all work together. So one of the comments was about ecosystem. I want to mention, highlight what we're doing with the ecosystem. We're not the only ones trying to build an ecosystem, and that's kind of the whole point of ecosystems. They start to overlap and connect. So this is just to show a bunch of logos of companies that we work with or that we collaborated with, either directly or through some of these standards. Some are more commercial relationships, others are more strategic. But the whole idea is, it really does take a village, right? You need lots of different pieces, whether it's mobile robots from Mir or Otto or Omron, whether it's infrastructure for charging the robots, wireless charging, for example, with robotic, whether it's sensors, software, all of these things need to come together. And I don't think they should be done on a purely case-by-case basis. You know, you pick 3 of these and you make it work for this particular customer, but then the next customer you need to start over. So that's why we want to be this kind of like more, call it abstraction layer for all of this. The other thing is, everything I just talked about is super abstract, right? So let's make this a little bit more real, right? And one of the things we've done is we created this, what we call the in-robit robot space. And it's in the heart of Silicon Valley, but it's on a pedestrian street with public access, or at least public visibility. The whole idea is, so when you talk to robotics people and you talk about general public, they get really, really scared. And it's super counterintuitive. But part of the goal is to showcase what happens in some of these environments that may not be accessible or visible to people. And we do a lot of things that are community-based, that I'll talk about. But really, it's a place where all of these robots can live from different vendors. Again, we don't make robots, so we get robots from different vendors. We're at the point where people send us their stuff. So I like to say it's kind of like a petting zoo for robots. And we actually have a couple of rescues too, I guess, in terms of robots. And I wanted to showcase some of our partners, right? Just to mention a few of them. So we have a Relay Robot, and they started by doing room service delivery in hotels. And they're deployed in over 100 hotels around the world. You may have forgotten your toothbrush sometime, and then Relay brought it to your door. We have outdoor robots, so there's lots of delivery, like sidewalk delivery robots. In this case, this is more of a researchy robot, but it has a GNSS, which is fancy GPS receiver, so it can be located outdoors. Mentioned Auto, Mir. Some of these companies are exhibiting here at Automate, so you should go see them. Big shout out to a company called Peer Robotics. They're another startup like us, and they may not be as well known as Auto, but they have some really interesting technology and robots. And then I wanted to mention as well, one of our partners, ecosystem partners, is a company called InStock. And they have these awesome robots that can actually climb walls and go upside down on the ceiling and then drop these like grappling hooks to pick up bits. It's really awesome to see. If we have time, my timer isn't working, by the way. So can you give me the 5 minutes, the hook? But I do have a video that I hope to be able to show in a minute. I talked a little bit about community, so we do a lot of things. We have robots for children that are, toy robots for children, age appropriate. We built like a toy warehouse where somebody from the sidewalk can control the robots and run them around. We have groups of government officials. We have groups of entrepreneurs from Japan that come through. So this is all part of building that community. And the community isn't local, and it goes beyond the people who attend Automate. We're partnering, for example, with a number of nonprofits. There's Women in Robotics often hosts, we help host our meetings. There's an educational nonprofit called SuperTech FT, and they do AI robotics training for disadvantaged high school students, and we hosted them and let them run like maybe 300K worth of robots, which is not something you can do every day. And then I think this is my video. I hope this works. Let me see. Okay, so that's an autonomous floor scrubber, right? Basically, you teach it where you want it to clean, and it cleans, and it has like a huge water tank, and keeps everything nice. You can see behind it, there's a relay robot. This is set up as a warehouse, so there's a manual pallet jack. We have picking robots, so again, if you stop by Zebra, for example, you'll see some of these robots used in warehouses. And this is the really cool in-stock robot that I mentioned. Okay, I see this every day, and I still think it's the coolest thing ever. But it's not just cool, it's actually useful. So what it's doing is it went to the second level, and it needs to pick up that bin that you just saw. So lower, it has what they call fingers that lock. You saw it right there, and then you can pick up. So great, so now you're on the ceiling, you have this bin hanging, right? And it can, I think it can lift like 30 kilograms. What is it going to do with it? Any ideas? Nobody? So you're going to go down the ramp with 30 kilograms of weight? Or is it going to ask a friend for some help? Okay, so now what's happening is the two robots on two different levels need to align. Maybe don't need to align with millimeter accuracy. They can't be off, right? Because otherwise that bin doesn't end up in the right place. Right? I can explain. So the point is, you have all of these different use cases. Now, with one of those, so that's by the way called an ASR, this automatic storage and retrieval system, right? So now, let's say you pull things out of the system, you need to replenish inventory. So in this case, imagine somebody brings cargo from even for the manufacturer. They bring a bin that's already preloaded with goods. And they're going to place them on this auto robot. Remember that use case I mentioned, collaboration, where you can't really complete a task with just a single robot, and maybe together they can. So usually, again, you have that. In this case, it's a ramp, but it could be a cargo bay where you're unloading the truck. And that's usually far away from where your goods-to-person system is. So what we're going to see, which I think this may be the first time that this is being shown, like this kind of problem or solution is being shown. So it enters the grid. Not sure if there are any Tron fans up there, just in case. And it uses its lift to position the bin at the right level. And then it's going to call a friend, but before we saw two friends of the same kind. Now we're going to see two friends of completely different kinds from different manufacturers that never talk to each other. They don't speak the same language, but it's possible to make them work together. And now this part, it's easier to anticipate. What is it going to do? It's going to lift that bin, but instead of lifting it off the floor or off one of its companions, it does it from this robot. Anyway, so I wanted to share some of these kind of like, you can see the increasing complexity here. And then I want to close with something that's a little bit more looking ahead. And if you look at all of those industries that I mentioned at the beginning, and you look at labor availability in a lot of countries, you look at places like Japan, where they have negative population growth, and I read this statistic, don't shoot the messenger. Every hour, there's 100 less people in the labor pool in Japan. And it's shrinking. So you have this aging population. They're aging out of working life. They're going to live for many years, and they need care. Does that sound familiar for the US and boomers? It's coming, right? Just Japan is maybe a couple of decades ahead. So I think what we need is more robots. Obviously, this is the Automate show, so of course there's a positive message about robots, but I really believe that if you think about that initial analogy of mainframes to PCs to smartphones and smartwatches, thinking 30 years ago, 50 years ago, go back as far as you want, about like 1 billion computers was like crazy talk. And now there's like 30 billion computers for 8 billion people. So I think despite places like Japan that have negative population growth, overall planet Earth is going to add 2 billion people by 2050. And we're going to need to feed them, even in the face of climate change. We're going to need to house them. We're going to need to deliver goods to them. And I think that can be done with robots. Thank you.
Thank you.